To celebrate our 50th video, we are going to do the reactions that a lot of viewers requested, the synthesis of a phenethylamine ketone starting from propiothanone. We've come up with a way that you can do this in one pot. But be warned, the intermediate bromoketone is still extremely hazardous and irritant. Plan the experiment and choose the apparatus carefully. We're going to make the ephedrone analog, which incorporates piperidine into its structure. Note that this product is unlikely to be pharmacologically active. We'll do this on a small scale and we'll use the dry 100 ml flask equipped with a magnetic stirrer. Our starting material is 1.5 grams of propiothanone. Ensure that this is dry, as we found that water inhibits the first reaction. For information about how to make propiothanone, check out some of our other videos. Add the propiothanone to the flask. Then prepare 5 ml of dichloromethane and use this to wash the container. Then add this to the flask. Here's our second starting material: bromine solution in dichloromethane. This solution contains around 0.45 grams of bromine for each gram of solution. Weigh out 4 grams corresponding to 1.79 grams of bromine. Check out our other video for details of how to make this yourself. Place the flask in a room temperature water bath, and secure a glass pipette tube leading into the flask as shown, connected to a hose. We'll use this to blow air through the apparatus, but don't put the pipette tube under the surface of the liquid, because otherwise it will cause too much DCM solvent to evaporate. Okay, stirring is on and we're ready to rock. Add 1 single drop of the DCM bromine solution to the flask. This first drop is the slowest to react, but soon the color will fade. As you slowly add the bromine drop by drop, you'll soon notice some smoke around the flask. At this point, switch on your vacuum pump and connect the output of the pump through a hose and use it to blow a bit of air through the apparatus. Not too much, just enough to remove some smoke. Then continue with the bromine addition dropwise, waiting until the color has faded before adding another drop. Addition is complete in about 15 minutes. At this point, leave the flask stirring for another 20 minutes to ensure complete reaction. And use the air blower occasionally to remove the hydrogen bromide smoke. You've now created an alpha bromoketone. It has a pleasant, interesting aroma of elderflower. And a second after you smell it, your eyes and face will start to burn. It's very nasty indeed, so use a lot of caution. After 20 minutes is up, use the air blower and keep going until the DCM solvent is removed and the yellow oil remains. At this point you can remove the air blower. We recommend that you make up the sodium hydroxide solution, which you can use to soak the used apparatus in. This will hydrolyze the bromoketone. Now for our third main ingredient. This is 1.7 grams of piperidine hydrochloride. This is our amine which will replace the bromine in the organic structure, creating our product. This isn't exactly a household item, but we actually made this sample here starting from white peppercorns. Check out our other video linked here to see how. Now measure out 3 ml of water. You want to make a saturated solution of your amine salt. Add this to the amine salt and stir. Looking good. Now place the flask containing the yellow oil into a cold water bath and get the temperature down to below 10 degrees C. Add the amine salt solution to the flask. At this point the amine is still a salt and the flask contents are still acidic with hydrobromic acid, so no reaction will occur just yet. Now measure out 1.2 grams of sodium hydroxide. This needs to be enough to convert all the amine salt to the free base form, and neutralize the mole equivalent of hydrogen bromide. Dissolve this in 3 ml of water and then cool the resulting hot solution down to below 10 degrees C. Now we're ready to start adding this slowly dropwise to the flask. As you add the first drop, the local temperature increase combined with the amine free base formation will generate a white smoke in the flask. Add the sodium hydroxide solution slowly over about a 5-minute period. Here's the flask on complete addition. Doesn't look much different. At this point, remove it from the water bath, and heat it gently on the hot plate, with vigorous stirring continuing. We tested a tiny sample of the reaction mixture using indicator paper to test that the pH was around 13. Continue heating on the hot plate until the temperature reaches 60 degrees C. Then switch off the heat and allow to cool back to room temperature again. Here's our completed reaction mixture, and the lachrymatory effect of the intermediate is now gone. We now need to work this up. Let's first get all organics into solution using 20 ml of dichloromethane. Add to the flask and swirl it around vigorously. Then add the mixture into a separating funnel. Use an extra 5 ml of DCM to wash out the reaction flask. The bottom layer is the DCM containing the organics. Separate this off into a flask. Then use a further 10 ml of DCM to extract the remaining aqueous layer. Allow to separate, then separate off the bottom DCM layer and combine with the previous one. We're now going to do an acid-base extraction to get our product free from other organic materials. First, place the dichloromethane solution back into a clean separating funnel. Now make up a solution of 20 ml of 10% hydrochloric acid. You can mix 6 ml of concentrated acid and add 14 ml of water. Add this to the separating funnel. This will convert our product back to the salt form, and make it soluble in the aqueous layer. Shake well and then allow the layers to separate. Separate off the bottom DCM layer. In theory this now doesn't contain any product, but reserve it just in case anything went wrong. Now make up a solution of 4 grams of sodium hydroxide in 25 ml of water, and chill it down. Add the cooled solution to the separating funnel containing our aqueous product. Once the hydroxide has neutralized excess hydrochloric acid, the free base product will start to separate as a cloudy emulsion. Again, we did a quick pH test to verify that the pH is around 13 and hence all our product is free-based. We'll extract using 15 ml of dichloromethane. Add this to the separating funnel and give the mixture a vigorous shake to get all the product into the organic layer. The resulting mixture may take a while to separate, so be patient. You can see that the cloudiness is all gone from the top aqueous layer. Separate the bottom DCM layer containing our product. Add a further 15 ml of dichloromethane to the funnel to break up any residual emulsion and extract again. Add some extra water if this helps as well. Remove the bottom DCM layer and combine with the previous one. Then dry using a little anhydrous magnesium sulfate. Pour the dried DCM product solution into a flask, and then evaporate off the solvent using a hot water bath and with a vacuum. Be sure to remove all solvent, otherwise the crystallization step will fail. You will be left with a yellow oil in the flask. This is our crude-free base product. There was a very faint aroma of piperidine in the background, but not much. Prepare a small amount of concentrated hydrochloric acid and add this drop-wise to the oil. You'll only need a few drops and be very careful not to add too much. We used 5 drops in total. Now add around 2 ml of acetone to the mixture, and then chill the flask in the freezer for 30 minutes or so. The product should crystallize out. If it doesn't, then either you use too much hydrochloric acid, or there is water present in the mixture, or there is some other solvent or organic impurity present. Set up for filtration and use a little acetone to transfer the contents of the flask into the filter. And here's our first batch of product after washing with a little acetone and drying thoroughly. 0.49 grams of white crystal. This isn't much, so we decided to extract a second batch from the filtrate. Since the hydrochloride salt of the product is very soluble in water, any water present in the acetone or on the glassware will lead to losses of product. We evaporated down the acetone filtrate in a small beaker on a hot plate. We were left with a brown syrup which we allowed to cool to room temperature. We added acetone to this to see if more product would crystallize out. And there it is, pretty rapidly dropping out of the mixture. Again we filtered this and used acetone to wash the beaker. And a little acetone to wash the crystal. And allowed them to dry. Here's our second batch of product. 0.36 grams of white crystal, but not quite as well formed as the first batch. In total that's 0.85 grams of product, which corresponds to a 35% yield on starting propionone. This seems like a low yield, but we couldn't find any reference for this exact compound to compare it against, so who knows. It's likely that there's still some product in the final filtrate and we could probably keep going and extract more. But we're happy with this and it seems like the fairly pure product that we've obtained. If you're tempted to try this reaction with primary amines, be warned that in the second reaction step these can cyclise under conditions of too much heat and too high pH to form pyrazines as impurities. We chose piperidine, which is a secondary amine, to avoid this complexity, and also because the product is unlikely to be pharmacologically active. We hope you enjoyed our 50th video. Stay tuned for more.